Announce to the group channel. All right. It's a little bit hot here. Let me switch up the heater.
Recording in progress.
All right. Happy Sunday, everyone. So good evening. And it's good to have you back in class. I'm going to share my screen now, and then we're going to talk about what we'll be doing today and how we're going to be progressing from where we stopped yesterday. I hope you guys can see my screen. Okay. Can you see my screen, guys?
Yeah, we can.
Yes, we can. Yes, we can.
All right, cool, brilliant. All right, let me. I hope everyone is okay with the Git repository. We're all, well, some of us were struggling with yesterday. I want to make sure that we all have access to the Git repository. And then for those who have been able to clone this, and you can see it, what I would like you to do today is to just run git pull, because there have been some updates. There's some push that I've done to this repo. As you can see, 5 minutes ago, I still pushed something. So you want to do a git pull so that you can pull the latest code. Well, it's not code, but latest updates to this repository. And by the way, this is how you would work in the real world. Imagine this was code. Every day you go into your office or you open up your laptop, if you're working remotely, you want to pull down the code repo very often, especially the master branch. Even if you're working in a feature branch, you always want to pull down that. But we'll talk about Git branching strategy as part of some of the classes we'll have soon. So not to worry. Okay, so let me go to AWS console. So yesterday, where we stopped was that we've already created the auto scaling for Nginx. So the good thing is that we now have Nginx auto scaling, and we can easily just scale this up. And we also have scaling policies in place so that if anything happens to the workload and there's a spike in CPU, we're guaranteed that this auto scaling group is going to scale to a maximum of 10 EC2 instances. And you can increase this as you like. If you want this to go to 100, 1,000, whatnot, you can keep scaling, as long as you know that you keep paying for AWS costs. So that's what matters most. And just a bit of a recap into the architecture. So we know what we're trying to achieve is to ensure that when we go to our browser, we can go to whatever URL, and then we ultimately reach our applications. So this is just 2 applications in this architecture. We can have more than that. So if you want to have multiple software, some may be mobile apps, some may be web apps, and some may be just static websites. It doesn't matter. We can have an auto-scaling group that is dedicated to each application. So regardless the number of applications running in this subnet, we want to make sure that our customers are able to drill down and reach the endpoints as we want them to. Okay. So someone talked about, someone asked a question yesterday regarding subnet. What if the IP address of a subnet, it's filled up, and what do you do? And that was someone who went for an interview, and we talked about that yesterday. One of the options I mentioned was that you can create a new subnet and relocate your workload to it, or you create a new subnet and extend your workload between your existing subnet to that subnet. Or I think the third one I mentioned was about secondary IPs, that there's a possibility for secondary IPs. But what I actually want to make reference to is someone then asked the question about LVMS. For some reason, I keep forgetting what he called it, like virtual extensible or something like that. VLSM. Thank you, VLSM. So I checked that out, but the reason I'm bringing that up is just to make sure that you're aware that that VLSM is not a solution to that, okay? So my understanding with VLSM is like you're just trying to further divide your subnets, just the same way you've divided your subnets, your network from the VPC and having subnet. Now you're being able to have, further division within the subnet. And there is some calculations to how that works. But essentially, it doesn't increase the number of IP addresses that you have in that subnet. And so it's not going to be a solution to that question. So I just wanted to quickly point that out since there was a discussion around it yesterday. Okay. All right. So where we are right now, we are, let me see. So this is what we did yesterday. So we actually, let me use I think what I'm going to do is let me bring up this note because I don't like the way it's looking here. Just bring this down, expand this. Okay.
Hello, Dari.
Yes.
Yeah. Still about the subnet thing. Is there a possibility of thinking of using maybe is it the IP6?
Oh yes. So you can use IPv6 in that scenario.
Yeah.
But of course, that is if your infrastructure has been designed to use IPv6 from start.
So it means it's like redesigning it from the scratch again, and then now start with IPv6.
Exactly.
Because that one is bigger.
Exactly, because it's bigger. And or if you have thought about IPv6 as an alternative to IPv4 right from the start.
Yeah.
Okay. Then of course, there's support for IPv6 already, then you can extend that. So that's another option to that.
So I actually want to comment on this problem.
Mm-hmm.
I think it all boils down to the way you divide your subnets, whether you use IPv6, because the problem is we are running out of IPs. So if you divide your subnets and you have fixed amount of IPs in your subnet, if it runs out, whether you're using IPv6, you still run into the problem.
True.
So I think the best way, the option is to maybe redesign another subnet and then move your workload there.
Well, so the thing you should also be aware of is if you switch over to IPv6 and start using IPv6, it could turn out that for your application, you can never exceed the availability of IPv6, right? Because even with IPv4, if you have 256 IP addresses in a subnet, it's possible that the way the application works is there can never be a need to go beyond 200, right? And you'll be fine with that. So if you exceed IPv4 and you exceed your 200 plus IP address and you switch to IPv6, let's assume IPv6 provides you another 1,000. It's possible you will never exceed that 1,000 and you'll be just fine with that, and there wouldn't be any need to start doing any kind of redesign.
So are you saying you can add both IPv4 and IPv6 in the subnet?
No, absolutely. Yes, you can have both. You can enable both IPv4 and IPv6 in the network. Yes. And that will be done from the VPC. So when you're creating your VPC, there are VPC settings you can do to enable IPv6 as well.
Yeah.
So that your have IPv6. Yeah.
Okay. Okay, so that way you have two sources of IP addresses.
Exactly.
Yeah, it's possible. It's possible. Even on the security group, you can see sometimes.
Yes, exactly. Even on you're right with that.
Mhm.
And then another thing, let me quickly show you something else. So this is also part of the VPC design right from the start. So it's possible that you already created secondary CIDR addresses on your VPC right from the beginning. Okay, so if you envisage that things like that could potentially happen. Okay, so this is our VPC here. So if I go here and edit CIDRs, you can see that I can add new IPv4 CIDR, and then I can now say 172.3.45.6/16, something like that, some random, something that can give me another 65,000 range, okay? So this means that if we exhaust here, we can then create new subnets based on a different range of CIDR and just add it to our network and allow it to span across, within the same subnet.
This actually solves the problem.
Then I think this is the answer then.
Yes, this solves the problem. That's the answer.
I mean, there is no unique answer. It depends on how you explain it.
Yeah, so there's just so many ways to cut, basically.
Hello, Mr. Dari, sorry to cut you short. So my question with this is, if you create a secondary VPC or a secondary address in this case now, how would you enable failovers to it?
So it's not about, this happens by design. So for example, let's go to auto-scaling group. Okay, this is our auto-scaling group for Nginx. Let's assume this is the workload that has this problem, yeah? And then let's edit this. Let's go into, let me see if you can see it. Okay, it's not here. Oh yeah, okay, this is it. So this is availability zones and subnet. So at the moment, we're using just two subnets. This subnet here, proxy 1, and this subnet, proxy 2. So this subnet right here has exhausted IP addresses, and this one as well. So we have a secondary IP that we've also created because the whole of this VPC has exhausted IPs, and we've now created a secondary IP. So what we can do is we can create a new subnet using that CIDR and add it to this part of the auto-scaling. So that when it's now creating more resources, more servers, it's now going to be using the IPs of that subnet. And we can add more, we have 2 right here. We can even add additional 2, and those 2 can span across these 2 availability zones. So we can create a new subnet in EU West 2A and another new subnet in EU West 2B and add those 2 to this auto scaling. So when it's now doing your scaling, it is now scaling across multiple subnets. So it's not like it's fixed to this one, because now we now have like a secondary subnet, and
Okay, so just my second question now is this. In this case, we are inside a private subnet. Now that's the case now. We're inside a private subnet. Now, assuming this was public now, assuming it was public now, will the IGW, will it be attached to it immediately, or we have to enable that manually?
So if you're creating a new subnet, what you're asking is you have to go into the routes table, and then you have to update the association in that route table. So if you go to this route table right here, okay, so we have an existing route table for the public. Where is it? Okay, we didn't name it public, but this is the route table for the public. and subnet associations. We only have these two. So if you created new subnets like that using the secondary IPs, all you have to do is to come and edit this and update it and enable those extra IPs so that it now makes use of this new subnets that's having the secondary IPs. So that way, it will make use of the internet gateway. Because remember, the internet gateway is based on the root. So if let me see, if I go back here, and then if I look at the root, you can see this is the internet gateway here. So the internet gateway is configured as part of this root. So the subnet that is associated to this root will make use of this internet gateway. Right?
Makes sense. Makes sense. Clear.
Okay, cool. So what we're going to be doing today is, even though we've created our Nginx in this private subnet and all that, we still can't reach it, obviously, because we haven't created a launch template and auto-scaling or however we want to do this Bastion, okay? Talking about Bastion, you can decide either to use auto-scaling for the Bastion or not. If you want to use auto-scaling for the Bastion, obviously you also probably or most likely going to need like a load balancer for the Bastion as well, and then have like a domain name you can use to SSH, so that anytime you're doing your SSH into your Bastion, you won't know which one in particular it's connecting to. So sometimes it will connect here, sometimes it will connect there. But that may not be a good use case because, you may just want a fixed Bastion. Ideally, you're not supposed to be keeping any data on any Bastion server. So you won't be creating your files or cloning a repository or whatnot. It's just a jump box. So if you're using it strictly for that, then that's fine. You can put it in an auto-scaling and put a load balancer in front of it. This time around, it's going to be a network load balancer. You can't use an application load balancer because you can't SSH into an application load balancer. It's operating on layer 7 of the OSI model. But with this, you're going to need a network load balancer, a classic load balancer that can work on layer 4 so that you can do things like SSH into it. But that's not what we're going to be doing. We're just going to create an auto-scaling group, launch template for Bastion, but there wouldn't be any load balancer for it. We'll just SSH directly to the IP address, okay? So once we do that, we can then hop into this Nginx and do whatever configuration we want. Then the next thing we will do is we'll now create internal load balancer so that this Nginx will now have configuration that sends traffic to this internal load balancer. So that means this Nginx right here is going to be working as a reverse proxy. So someone was asking the question today, I think it was Somex, and I was trying to explain the differences between load balancer and reverse proxy. So in this case, this Nginx is not serving as a load balancer. It's actually serving as a reverse proxy because all it's doing is just taking a request and forwarding it on, okay, to this load balancer. And this load balancer would then load balance traffic to either this or that. So this is the one that is going to be spreading the load based on who it thinks that needs that request. So if it is this tooling site that requires it, it receives it, and then it sends it to this tooling site. So how does this load balancer know that it is this tooling site that needs it? We'll talk about that. Or how does it know that it's going to be WordPress or any other application that we have configured there? So we'll talk about all of that. Then the rest, I would want you guys to go ahead and finish the rest and do it yourself. The reason is because, first of all, this project, I want to assume is not new to you. You've done it already from project 15. And apart from that, working with NFS is something I believe every one of you have worked on, right from projects, I think 7, 8, 9, and all that. But rather than spin up a server and implement NFS onto it, where you have to manage it, because you remember, when you implement NFS, you are mounting the NFS mount points to your servers, and you're making sure that they can share the data. But you have to remember that if you don't implement high availability for your NFS, it can serve as a single point of failure. Because imagine if you had your NFS running on one server and your NFS server goes down, that means your applications are going to break because the data they need that is mounted on the server is not available. So that's where Amazon's EFS comes in. So it's a highly available, highly scalable NFS solution. But rather than call it NFS, Amazon has called it Elastic File System. So it's a software that you just have to provision, like you would normally provision Internet Gateway or RDS or whatnot. And you just have that, you mount it on your servers. And without thinking about it, without worrying about availability or whatnot, Amazon takes care of it. So that has to be in the same subnet as your compute applications, because even though it's a data layer, if you put it in this subnet right here, it's not going to work. Okay, so that's one thing you should bear in mind when you're doing this. So once I'll guide you, I'll show you what you need to know, what you need to care about, but I do want you to be able to do this yourself so that you gain the experience on actually spinning up an EFS instance and then mounting it onto your applications. But bear in mind, it must be in the same subnet as your workload, your compute service. RDS can be in a separate instance. So what I'll do is I'll spin the RDS up so you can see the processes that it takes to spin that up. I can also spin up the EFS as well, but the actual configuration to connect, for example, your tooling app to your MySQL database, I'd expect you to do that so that you know what application files you need to go into the tooling app to update and just make sure that you're able to connect to them. But we'll create the necessary security groups that make sure that there's connectivity between them. And then for EFS as well, I'll give you some guide about how that works. Now, if you come back next week, if you're unable to do this, then we'll do it in class. But I want you to, first of all, have the experience on doing that. So that's what we're going to be doing today. I hope we'll have enough time to go through all of that. But let's carry on. So if I go into our auto scaling, so we have this. So let's bring up our. So what I did since yesterday, I just turned it to 0 so that it can terminate the instances. And that's one good thing about auto scaling groups, because it basically ensures that you don't keep on running your servers, and then when it's time to bring up the server again, you don't have to go and click, spin up a new server. You just increment the number and it just brings everything back up for you. Obviously, because you have a launch template, okay? So let's go into, I'm gonna close this off. Let's go into our instances section. All right. And so it's initializing at the moment. Yes.
Yeah. So actually, I've done this project, but I was thinking about something just in case of others to make it more interesting. So okay. Because when I was reading through the documentation, it got confusing about auto scaling group, launch templates, a lot of things. So I think the same way we have architecture the same way we have architecture diagram in order to understand the architecture very well. I think we can have something like a flow chart that speaks to what an auto-scaling group does, how it picks a template from the launch template and provision it, and just the flow from how all of them
connect together.
You connect together, because I got really confused. I have to tell myself a story about it for me to understand very well.
Okay, thanks. I think I'll take that as a feedback. So thank you very much for that. So I guess what we can do is we can even leverage on these steps right here, because the way I put all these steps together, we can put like a flow chart that says, do this and then go to the next and do that. So yeah, I'll take that as a feedback and we'll definitely work on that. Thanks. Okay, so so what we want to do now is we want to try and connect to our Nginx because we've spun up our Nginx, but we want to try and connect it and see what's going on. So everything is up and running, but it doesn't have a public IP, obviously, because it's within a private subnet. And so what we need to do is to create a launch template for the Bastion and then create the auto-scaling group for the Bastion so that we can then hop onto this Nginx. So let's do that. So I'm going to come here so we can create auto-scaling launch template for Bastion. Create launch template. So MCC Bastion, launch template Bastion. And then for our Bastion, we would use Ubuntu. Let me go back. Oops. Sorry. Start again. Okay, what I wanted to look for, okay, I was looking for this quick start. So if I click on this quick start, it already has some template. I can just click on this Ubuntu right here and it will populate it for me. So that's what I was looking for. Okay, so instance type, we can use the free tier here because it's just a jump box, something very lightweight is fine. And then the key pair, we're going to use the same key pair so that we can use the same private key to hop onto it, and then we can use the same private key to hop onto the Nginx. Now, you might be thinking, well, is that not a security loophole? Because if someone gets hold of this private key, then what's the whole point of separating the networks? Because obviously the same person will be able to get into the Bastion and then also get into the Nginx. But you have to know that, first of all, this private key is not going to be the same one that everyone is going to share within the team. When you're joining the organization, you're going to have your own private key. Okay, you're going to have your own private key, and that's why it's a private key. It has to remain private. So you want to make sure you guard it and you don't expose it unnecessarily. That will make it to get in the hands of bad people. Now, the good thing though is there are tools that can ensure that this key can be rotated much more frequently, so that if you have a policy in your organization to rotate the keys every month, that means the same key that was working a few weeks ago will not work, today after it's been rotated. And that rotation can be automated that you don't even have to know anything about it. It changes the key, it rotates it, updates all the existing servers, all the upstream servers, the public key and authorized key files there. It does all of that without you knowing anything about it. So HashiCorp Vault is one of the tools that makes that possible because it's all about security and automation, okay? So we'll see an example of how this kind of rotation works somewhere down the line, especially when we start working with Kubernetes. So that was just a passing comment so you know. But for now, we're just going to use the same key, assuming that this key, if I was the engineer and I'm being onboarded into the team and my name is Dari, obviously this key will be named Dari and that's my key, okay? So I'm going to use the same key to hop onto the machines. Okay, so network settings. So what we're going to do, I believe we have, so for Bastion, I believe we already have, we have a security group for Bastion already. So I'm going to select that. Okay, and storage is fine. Then I think that's it. So we're not going to do user data for now. Okay, I'm going to talk about user data shortly. I have reasons why I haven't shown you that. So let's just create it.
Won't you add an IP, a network interface?
Okay. I actually wanted to, so you've just moved ahead of me. I, on purpose, haven't done that so I can show you guys, the effects of what's going on. But it's a good thing you mentioned that. But anyway, let's just go and see what gets created. And then that will lead us into that. So let's refresh this. Okay, no, we haven't actually created the auto-scaling group. So let's go ahead and create the auto-scaling group. Then we'll select the Bastion launch template. Let's select our VPC, and then our subnet will be the public subnet. So the first one, and let's get the second one. So the reason for this is in the case where we spin up two Bastion hosts, we just have one in one subnet and the other one in the other subnet. Similar to what we have in this architecture here and there, okay? We don't need a load balancer for this, okay? And we can just leave everything as is. We just leave it one. We don't need more than one. For this tracking policy, do we need this? Let's just leave it at none, okay? And then we can just, let's give it a tag. All right, so now we have our Bastion updating. We can refresh and see where we are with things. So 111, everything looks good right there. And let's see if it has started provisioning it. So now it's provisioned an EC2 server. And then, so this is where what you were talking about. So as you can see, it doesn't have a public IP address, okay? Doesn't have a public IP address, and without a public IP address, there's no way we can get into it because it's just like a private IP. So even though it's in a public subnet, we know we have configured the public subnet to have the internet gateway, to have routes to the internet. We already have all that configuration, but still it doesn't have a public IP address. So what you have to bear in mind is there are certain settings that has to be done on the subnet level that goes down onto the instances that gets created in that subnet. So this configuration has to happen from the subnet level, not even from the launch templates or the auto scaling. So if I go into our VPC menu, so let's click on VPC. And if I go into subnet, so let's get the first public subnet. So this is our MCC public. And then we can go into edit subnet settings. So this is the part that we missed when we were creating this subnet. And on purpose, I didn't check this box so that, we can see the effect when you create servers in a public subnet and you still don't get to see your IP. I mean, these are kind of problems that someone might spend a whole week trying to figure out. And the solution is just enabling this feature. So enable auto assign public IPv4 address. And then if you save that, that means that anytime you now launch a server in that subnet, it will then have a public IP. So we'll do that with the second subnet as well, just in case it's provisions that server in that in the second subnet. Okay, so what's going to happen is there's no way we can change this to have that public IP because it's been provisioned already. So what we'll do is we just terminate this instance, okay, and we just allow auto scaling to provision a new server. So that's one beautiful thing about auto-scaling. We don't have to try to provision anything. It's just going to take care of it by itself. So auto-scaling group would have received an event notification that, oh, there is a server that is shutting down. And because it has a setting to have a desired state to be 1 and minimum number of servers to be 1, it would always make sure that there's one running. So now that this is terminated, it will spin up a new one. So let's just give it a bit of time.
I have a question.
Mm-hmm.
So my question is, if we are not optimizing for cost, that means we will have 2 Bastion in different AZ. Are we to create them as we are going to create them ourselves and put them in? Because when you created this, you added 2 subnets.
Yeah.
But it's created it in one AZ. So we have to create another Bastion and also add the 2 subnets. So how do we place it in the second AZ? That's basically my question.
Okay, so if you want it in the second AZ, all you need to do is just increase the count of your auto-scaling group. If you increase it from 1 to 2, it will spread the load. It will put one in AZ1, put the second one in AZ2.
Okay, so the auto-scaling group is the one that charges the amount of instance that is being created. Okay.
Yes. So it takes care of the balancing, making sure that there's like a round robin type of balancing happening between the 2 availability zones.
So we just get to create one instance. The auto-scaling group will take charge of spreading it.
Yes. So if you increase the count of the machines, auto-scaling will just create a new one and put it in the second AZ.
Okay. Thanks.
So we now have the second Bastion created. Okay, so if we check this one now, as you can see, now it has a public IP address. So we can take this and we can go to our terminal and now try to connect to that server. Okay, so let's do that. So if I do, I do know that the key that I downloaded is in my downloads folder, and this is the key right here. Okay, so what I'm going to do is I'm going to type my SSH command. So SSH, it's an Ubuntu server. So the username is Ubuntu. Actually, before Ubuntu, I need to put -I to specify the private key. Okay, so that's the identity to log on. Is this large now, or do you want me to enlarge it? Let me just enlarge it a little bit more. Okay, all right. And now that we have that, we can then do Ubuntu at the IP address and hit enter. So because security group, the firewall setting is correct, everything is there, it basically just jumps onto the server. And now we've gotten there. The next thing is we need to get onto our Nginx server. So now, if we try to get into our Nginx server, we need to get the private IP address, okay? So we get the private IP address. And does anybody know which OS our Nginx server is? Is it Ubuntu?
Red Hat.
It's Red Hat, thank you. And do you know what the default username for Red Hat is? Because with Ubuntu,
EC2 user.
EC2 user.
Perfect, thank you. So what we now have to do is we have to do SSH, okay? But the question is, do we have the private key that we use to hop onto this machine? Do we have it on this Ubuntu box? Well,
no.
So because if we go into the SSH folder, we don't have it here. So this is where we now have to find a way to either bring the private IP on this server. So we can either copy the private key and then create it as a file on this server and then do our SSH as normal and say -I, specify the identity, which is the private key, and then specify EC2 user at the IP address. So that's one option. But is that a good way of doing things? Copying our private keys around. I mean, there's another command we can use, which is the SSH copy ID, which is not the agents at the moment. There's one command which is the SSH copy ID, which basically physically copies the private key from one server to another without manually copying it, you know. But even that, we don't just want to keep copying our private keys all around, because that means you're exposing your private key. And we don't want to do that. As much as possible, you want your private key to remain on your server or on your laptop, or, you know, where it is. You just want to guard it and protect it as much as you can. So that's where the SSH agent now comes in. So you can use the SSH agent, and it has an inbuilt functionality that internally it transfers the private key, and it's going to be virtual. You don't get to see it physically. There's no way you can find it on the server. If you do an ls in the SSH hidden folder, you won't find it there. So that's what we're going to do. And even this node is part of the things that I've updated in this our note right here. So if you scroll all the way down, I've put it here under the annex section. So what I've done, so let me exit, okay? So you know that this is how I connected to my server. So what I'm going to do is I'm going to store this as a variable, first of all, so that it just looks neat. And, you know, from time to time, you should invite this kind of thing. So I'll just say key. It could be anything. I mean, you could even call it, let me just call it MCC key, right? Equals the location of this private key on my laptop, right? And then rather than do my SSH -I and specify the path like that, I could just do $MCC key, and it knows that it's talking about this because I've stored it in a variable, okay? So that's what this is all about. But before we go into this, let me just save this first of all. So I've just put a £sign there to show that do not run this command. So what we want to do is we want to run this SSH agent command. So if you run eval SSH agent, it's like enabling the agent. You can see it now has an agent ID. And then I can add this private key into the SSH agent. So if I do SSH-add, and then the variable I have used here, the reason I use this other variable different from what you have in your nodes is just to show you that it doesn't have to be key. It could be anything you name it. So now I've said SSH-add this our key. So you can see here it says identity added, and it's telling me the location of the identity. So now to run our SSH command, all I have to do now is to add a capital A before this I, because the I means identity, and that's what specifies this identity. But this capital A, what it does, let me put the £sign again, so we're not going to execute that. Let's do SSH-help. Let's see if there is a capital A here. Does anybody see capital A? All right, no. Let me see if there is man page for SSH. Oh yeah, there is. So what I've done is I've run man SSH. So basically, it's going to open up the manual for SSH. Okay. And then let's see if it has the hyphen capital A, so we can read the instruction there. Let me search for it. Oh yeah, there we go. Hyphen capital A enables forwarding of connections from an authenticated agent such as SSH agent. This can also be specified on the per host basis and configuration file. So agent forwarding should be enabled with caution. Users with the ability to bypass file permissions on the remote host can access the local agent through the forward connection. So this is just a warning to say that, you have to be careful with using this. Every time you enable the SSH agent, once you're done with it, you want to make sure that you find a way to close it. You can close your session, just terminate it. But what I want you to see is it enables forwarding of connections from an authenticated authentication agent. It's not really doing good justice to the description, to be honest. But one thing you should bear in mind is what it's doing for us here is it's making sure that whatever connection information we have used to get onto the first server, it extends that same connection configuration to the upstream servers that will be connected to after we have reached the first one. So if I hit on this right now, it's going to get into the Ubuntu Jump box, which is our Bastion server. And now, if I go to our Nginx and copy this IP address, and then I do SSH EC2 user at the IP address, you can see it's not attempting to connect. So I'm going to type in yes. And now we're connected to it without specifying any IP, any private key. Okay, so this is how to do things like this. Just in case you find yourself in a situation where you have to connect to some server, but the private key is not on the jump box, and you're wondering, should I copy the private key physically or whatnot? So this is a good way to do it. Well, now that we are on our Nginx server, what are we interested in? Well, first of all, we want to make sure that there's Nginx running on this box. So if I do systemctl status Nginx, well, you can see we don't have Nginx. So that means we have to install Nginx on this server. Now the question is, how do we get Nginx installed on the server? Well, we can either do it manually, but the ideal way would have been to use the the user data from the launch template. So you can see when I was talking about the launch template here, the advanced section, advanced details, if I scroll down, you can see here the user data here is empty. So there is no script that runs here. So if we modify this template, take note here, it's going to say, it's saying modify template, create new version. So it's not going to delete the existing version. You can see here versions, there's only one default version here, which is the very first one, number 1. So if I try to modify this, it's going to try to create a new version. And then now we're going to have version 1, version 2. So if I scroll all the way down, go to the advanced details and scroll down, you see the user data section. If you click on info, it says here, specify user data to provide command or a command to script or a command script to run when you launch your instance. So when the instance gets launched, you want this command to run basically so that Nginx just becomes available by default. Now, before we do that, let's have a look at our diagram again. So this load balancer that we created here, this external facing load balancer, we've created a target group that takes it to Nginx. And when you install Nginx, by default, it has this Nginx page. So that's what we should see. So we take the address of this load balancer, for example. Ideally, it should take us to Nginx, right? So let's go to load balancer. So we have this public load balancer. If we get the DNS name and we go here to the browser, right here it's showing Nginx. Oh, actually, I wasn't expecting this to show Nginx. So let's see. Okay, this is actually coming from a cache, I believe so, because I had done this previously. So let me try to use incognito. And let's see if it's going to work. 1 second. So this is an incognito window. You can see incognito here. Let me see if it's going to work. Okay, good. So this is what I expected to see. So there's a 502 bad gateway. The reason why this has worked is because I had tried this previously where we had Nginx installed, but it's still loading a saved content on my browser. So it's not actually hitting the server. This is just a cached data. So it's either I clear my browsing data, history, cookies, and things like that for this to go away. But anyway, we'll leave this for now so that we can use the incognito. And that's why it's, you can see why it's very important when you're testing your development. For those who are developers here can testify that it's a very important practice that you use things like incognito to test your applications from time to time when you're developing features and you want to be able to see whether things have changed. Same thing happens with infrastructure configurations as well, because you're making changes to infrastructure configurations, you want to test it. You know, you don't want to be deceived that things are working, whereas it's using a cached information on your browser, okay? So we know, and by the way, I can send this to you guys. Let me send it in Slack so that you can keep track of this, okay? So I'll pull this away. So on our Nginx server itself, we know that Nginx is not installed. So what we're going to do is we're going to use our we're going to modify the launch template and put a user data here. So the script you're going to run here, I have it here already. So let's find it. So it's going to be this script. So let's go through this. So it's using bash, and it's going to say, well, sudo yum update. Now this takes a bit of time, so we're going to have to wait for it to finish up running. And then we have yum install. So it's going to install this. Actually, 1 second. Let me see what version of OS we have. So if I do cat etc OS release, so we have version 8. Okay, so that wouldn't work. This should be 8 because the version 7 we have here is not going to make it to work. Okay, what I would say is let's test this first of all without putting it into user data. Let's put it as a script on the server and let's see if it's going to work. So let's create a script vi. Let's name it user data. .sh and put the script in there. So I'll change the permission of this script to make it executable. And then I will execute the script. And let's see what happens. So if this works, then we're good. We can just put the same script in our user data. It will take a bit of time. So let's spend this time to chat, right? So if anybody has any questions, let's just quickly talk about that.
Okay, I have a question concerning the SSH agent. So like, does the two servers, let's say the server A and server B, must they have the same SSH public key? If you must use the SSH agent to move from localhost to A then to B, but must both of them have the same public key on the servers?
Yes. So the authorized key file must already have information about who it expects to connect to it, which usually contains the public key.
All right.
Yes.
Thanks.
If it doesn't have that, it won't work.
All right, thanks.
Cool.
Yeah, I have a question.
Yeah, go for it.
Yeah, so suppose you're working in a company and they need to share the private key. I don't know. Is it a possibility like they will, in the company, they will already attach the key to an SSH agent before sharing it, or because like you said you, Dari, will have your own, me, McDonald, I will have my own key. But I just feel like for every instance, there is a particular key. It's not like particular to the worker. I don't know, maybe you can share some light on that, please.
Yeah, so, I mean, you know, the SSH key really is per user. So in the case of our Ubuntu server, there is a user on the Ubuntu server called Ubuntu that key has been associated with. I can create more users. I can create Dari user, I can create McDonald user, and each of those users will have their own unique key pairs, which is private and public keys. So when you join an establishment, your user doesn't already exist before you joined, right?
Yes.
Now you've joined, they will create your user account on the server. When they create the user account, they create a key pair for you. Ideally, they would even tell you to go and create the key pair.
Yeah.
Okay? You can create the key pair on your laptop because they shouldn't even know about your private key. So what they will say to you is, McDonald, go ahead, create your key pair. You can do that on your MacBook or your Windows server as long as you have something like a Git bash. And then you run your SSH keygen command, it creates your key pair. So what you would do is you will send them your public key and hold on to your private key. So it is the public key that you give to them that they will put on all the servers that they want you to have access to. Okay. So no one would ever have your private key in the first place.
Yeah. If I've understood well, it looks like it's more about the user, but I'm talking about what about the servers that are running. So suppose you are a user, yeah?
Yeah.
Yes, and there is already a server that is running in there. I was thinking each of those servers that are running, they are being run or created from the onset with a private key. It's not about me, the user. I mean, the server itself is being created with a private key. So me accessing those servers, that's what I'm talking about. If I one user, user A is having a different private key than user B, you know, how do we all access that same server? Or maybe we won't have the right based on some rules. We won't have the right to access that.
Okay, so the reason why you're thinking like this is because when we're creating this server, you saw that we generated a key pair. And you're thinking, oh, we're all going to use that key pair. No. Ideally, that key pair should not be used by anyone. That key was just generated so that whoever is setting up the servers for the first time would have access to it. No one else should be using that key at all. Okay. So for you to access the server, you need your own unique key pair.
Okay.
The second user needs his own unique key pair. No one is ever going to be using this one that we've created.
Okay, I now see.
Okay.
Yes.
Yes. So imagine you create this server for the first time and the key that was created is being shared to everyone in the team. That's a bad practice because if anything happens, we don't even know who did it because everybody will be connecting with the same user ID using the same key.
Yeah.
And there wouldn't be proper auditing for things like that.
Yeah, I was a little bit concerned about everyone having the private key of the server. It means everyone can just do whatever.
Exactly.
Yeah.
Yeah.
Yeah. Thank you.
Cool.
I have a question.
So there, okay.
Yeah.
From the answer now, So like, yeah, that's a very good practice. But if you have so many servers, so you, of course, you won't be adding to all of them one by one, because let's say you have 10 DevOps engineers join the team and you have like 100 servers. So how would you automatically make that happen?
Ansible.
Okay, yeah, sure.
Ansible is the answer. It's not something you're going to be doing manually. So if you're using a configuration management tool like Ansible, then it's just adding one line of code to your existing Ansible playbook, and then you just run it, and then it loads up all the users. If the configuration management tool is Puppet or Chef or Salt, whatever configuration management tool, that's the purpose of configuration management. So it doesn't matter whether it's 100 servers or 1,000 servers, you have the same scripts, you run it across all your servers, and it adds the public key there. And whichever server you want to connect to, the key is waiting there for you and you can connect to it.
All right.
Okay, cool. Okay, so we have the scripts completed now. Let's see if Nginx is not right. Okay, so that means that script will work. So now we have Nginx running. If I bring back this is our load balancer, and I refresh it, now we can see that Nginx has loaded. So what this means is right now, we're able to go from here, even though we're not using the DNS at the moment, we're just using the load balancer address directly. So we'll go here. Now it hits the load balancer, which is what we've done. We've hit the load balancer. And it goes through the target group, which contains the Nginx servers. Nginx is running there fine, and then it loads the web page to us. So this is perfect. This is good. So what we want to do next is to make sure that Nginx receives that traffic and it's able to forward it on to the relevant applications. And once we do that, get the application connected to database, EFS, whatnot, our job is done. But of course, it doesn't mean that we have a perfect infrastructure, like I said yesterday. Most of the time, infrastructures, and that's why, I love this profession so much. You will never run out of job because there is always going to be something to be done. There will be security patches that needs to happen. There will be some security improvements that needs to happen. There is some level of manual work that was done when we were initially doing it that needs to be automated. So there will always be work for DevOps to do. I mean, it gets busy every single day, okay? So once you have an infrastructure like this, you set the whole thing up, this kind of architecture can take a team, in some cases can take a team, I'm not exaggerating here, in some cases you can find some teams spend like 6 months to 1 year to implement something like this, seriously. And there can be many reasons for that. It depends on the company. In some cases, it's a situation where the organization has hired a consultancy to implement something for them. And because, the consultancy, they want to have reason to always coming back, they know how to prolong the project. So a project that could have taken maybe, even if you were the only one that was hired, you probably do this whole thing in 1 week and hand it over. But some consultancies will make sure it lasts for a long time, and eventually, they hand it off and still hide some things in there that will make them always come back. This is not a professional thing, but it's some of the political things that happen in the real world. In some cases, it might just be a case where there are a lot of bottlenecks in the organization. So it's a different team that is taking care of networking. It's a different team that is taking care of databases. And, there will be blockers along the line. Sometimes you need to implement something. The network team are not responding in time. It takes a long time before you get a response. And, things like that can take a long time before the whole project gets completed. So, but if you were working with like a startup and they hired you as the only DevOps engineer and you're a permanent staff. It's not like you're a contractor that you're worried that after your contract, they're not going to need your service anymore. You know, this kind of solution will probably take you 1 month or 2 months to put everything together, write the automation script, get everything going. Maximum maybe 3 months, you know, you hand over the whole thing back. But whichever the case is, you know, let's assume that we'll spend whatever time and we've reached where we are. So what we want to do next is to ensure that we can now create the necessary configurations to do the rest of the solution. So let's create our internal load balancer. So we're going to create another load balancer now that will receive traffic from the Nginx, because anytime we read the Nginx, we want Nginx to forward the traffic. So once we create that, we can then go back to Nginx, do Nginx configuration to now start talking to the load balancer. And then we need to create the security group as well that this internal load balancer is going to use. Let's have a look at our notes and see what we have. So we've done this user data part. We've done this. And by the way, this same script that we just ran, we could put that in this launch template. So let's do that actually. Let's do that. So let's copy this. And then let's put it in our launch template. So it's just the same script the way it is. Create a version for it. Okay. But take note, the version, the default version is default. Okay. So we now have a new version. So ignore the fact that you're seeing 12. In your case, what you'll see is 2. The reason why you're seeing 12 here is because I have done a lot of testing with this. And the last testing I did was 11. I deleted the whole thing, but now it's coming up as 12. So that's the reason why you're seeing 12 here. So don't get confused when you're doing this. But what I'm going to do now is I'm going to go into the auto scaling group and edit this auto scaling group. In your case, if you're doing this for the first time, what you will see is let me see the version. Okay, so the version section, what you will see is you'll see something like default like that. So you want to make sure you're using latest. Okay, so the current latest is 12. You know, like I said, but in your case, it's going to be 2. So let's make sure that anytime we make a new version of the launch template, it's always using the latest, because one of the things you would experience is you make a change to your launch template and then you try to test it with the auto scaling group and you expect it to pick up the changes and you notice the changes is not getting picked. It's because if you look at the Bastion one, the version is set to picking up the default, and the default can be the very first one. But if you always select the latest, anytime you make updates to your launch template, it will always pick up the latest version, okay? That's what makes it different with launch configuration, because launch configurations does not have the whole versioning concept. Okay, so now that we know we've updated this, what we can do is we can go back into our instances. Let's go into EC2 section. Okay, and then we're going to terminate this. So you guys can run, you can test from the load balancer that I sent to you and see what happens. Instance state, I want to terminate this instance so that it will spin up a new one, but using the new launch template. Okay. So if I bring up that browser again, where is it? If I refresh this, it's gone because the server has gone. So that's where you see 503 error.
Hello, Dari.
Yes?
Yeah, on the new configuration that you just did on Nginx, I can see that you did not put like just an additional line of enabling the system control.
Yes.
CTA.
Yes. Thanks for spotting that out. Yeah, it's very important to have that enabled because so that if the server restarts, it would always be enabled by default. But bear in mind, we're working with auto-scaling group here. So if for any reason the server stops, okay, it will always spin up a new one. Always. So in this case, the enable may not have so much effect because if the server stopped for any reason at all, auto-scaling is going to terminate it and bring up a new one. So, and every time it brings up a new one, it's going to run the launch template that has that script and it will just load it.
Okay.
So, yeah, so that's the only reason why the enable doesn't really make so much effect in this case.
Okay, thank you.
You're welcome. Okay, so we now have it. Yes?
Gary, please could you shed more light on scaling up and down?
Scaling up and down.
Yeah.
Okay. So the reason why we need scaling is so that anytime our servers are used up to the point where one server can no longer handle the request anymore, we are going to need another server so that the load can spread. Imagine if, as a human being, okay, imagine if two people are talking to me at the same time. As a human being, it's just going to be hard for me to comprehend that two people are talking to me at the same time. My CPU level will spike up, right? So what I would need is for one person to talk to me at the same time, and then the second person will talk to another person at the same time, and then maybe later on, both of us can consolidate our findings and all that we've received and send it off to one person. But essentially, it becomes a bottleneck when there is too much load on one server. So that's the reason why we want to scale and increase the number of servers that receives requests from the browser or from the client. Okay? Now, the whole scaling configuration is done with Amazon's auto-scaling group. And the way it works is you put some group of servers in that container. It's like a container. So you put some group of servers in it so that when there is need to scale, and why will there be need to scale? Well, when the CPU level has gone up. And of course, that is the configuration we've set. We can also set a configuration to say if the memory usage goes up or the load on the network, if it gets load up as well, whatever scaling events that we want to track or whatever scaling events that triggers an action that we want to track, once that event shoots up and hits a certain threshold, what auto-scaling group is going to do is it's going to create another replica of the server. It's going to be exactly like the initial server that was running, but it will now be a second server. And with the auto-scaling group configuration, like if I go down here, auto-scaling group here, so with this particular one, if I go into edit, you can see here, we say the desired capacity 1, minimum capacity 1, maximum 10. So that means it can keep increasing the number of servers up until it gets to 10. Okay? So ultimately, if there is so much load, maybe 100 million or 200 million users are using the website at the same time, and we need at least 10 different servers to handle all of the load, then auto-scaling group will keep on creating servers up until it reaches 10. Or whatever we configure. We could have configured 50 or 70 or 60 or anything like that. Do you understand? So that is what scaling is all about. Scale means to increase the capacity of something. So I hope that is explanatory enough for you.
Please, Barry, please. There's I'm still on the same topic. Not that we can have we can have multi-AZs.
Yeah.
Yeah, but can we load balance into multi-regions? Is that possible?
So that's a good question, actually. It's not something that I've actually tried or a setup that I've seen a lot, but it's something that we can actually check together online. I don't know if it does multi-region scaling. So AWS multi-region scaling. I haven't seen the configuration for that, but maybe there is, we'll see. So you can see here, it says it cannot scale or span multiple regions.
Yeah.
So I haven't seen that kind of configuration. What I've seen, is multi-AZ. So yeah, that answers the question.
Okay, thanks.
Okay, so let's see if our let's see if this has worked. Okay, so it's still now giving us 502 now, but obviously we know that. Yes.
Yeah. So it was a question that I was asked in the interview.
Mm-hmm.
It was all about if the end users are complaining about your application, and what will you do? And my answer, I don't know if it was okay. And I told them that you download the load balancer log, then you check what is going on with the application. Then I said, how will you check? I said, it's either you check by date or by the application. Then I said, after that, what will you do?
Okay. So this kind of question is not one that you want to quickly start talking about, going into logs.
All right.
This kind of question, depending on the interviewer, there's a whole lot of things that they want to get out of you based on your response.
All right.
First of all, you can use it as an opportunity for them to understand that you are a well-versed engineer that understands things right from the architecture level all the way down to supporting the infrastructure after it's gone live. So one of the things that you want to talk about, first of all, is when people start complaining, users are complaining, it could be that servers or the website is running slow, or that, there's some errors happening in the web console, whatever. One of the things you want to start talking about, first of all, is you want to identify, first of all, if there are monitoring solutions available as part of the infrastructure. That's where you want to go, first of all. You want to go into the dashboard of your monitoring app. It could be Grafana, Datadog, New Relic,
Elasticsearch.
Elasticsearch, whatever monitoring that you have. You want to go in there, first of all, and have a look at the patterns. So is there a pattern of a steady flow of traffic and all the way it's dropped somewhere? From your monitoring tool, you can drill down and have an idea of what's going on. Is it that things are slow? Is it network? Is it CPU? Is it RAM? What has happened? Okay. It also depends on the message or the complaint. Because if the complaint obviously is that things are slow, then just going into monitoring is definitely the first point of place you want to go into. Or it could even be CloudWatch in AWS, okay? But if the problem is that, like something like this, all of a sudden, a website that was working is now having a 502 bad gateway error, okay? First thing first, your knowledge about your infrastructure is very important. So if this is some domain, maybe tooling.dari.io, obviously that has to do with the tooling app. So you can go straight into the tooling application. before you even go through the load balancer, you want to go straight to the application logs first. So you get into the server, have a look into the application logs, see if there's a pattern of something going on. Is there traffic coming through to the application? Okay. If you go into the log and you see that, well, the application itself is receiving traffic, but it could be a case where there are multiple layers of proxies before it reaches the application. What if there's a proxy in between? You want to check that proxy. Is that proxy receiving traffic? Check the logs of that proxy as well. Okay. So before you even go to the load balancer of AWS, you want to go into those, infrastructure components that's been deployed that is actually servicing the request. Because you want to bear in mind that the chances of AWS load balancers failing is minimal. The chances of your application that you've configured failing is much more than AWS that has provisioned a managed service that has 99.99999 something availability. So you don't want to go and start looking at the application, the load balancer of AWS, first of all. You want to go into your application. So check the logs of the application, check the monitoring you have in place, look at the logs. If you have a centralized log like Elasticsearch, you want to go there, have a look through Kibana, search through the dates. So that's where the dates can now come in. So now you know when the error was reported. You can then filter by dates and see, okay, from when the chart started changing, what has happened. Now, if you look through the logs, you look through the monitoring and things like that, you can ask around. Because the question could also be the database. It may not even be the application. So you can ask around with, what's the latest change that has occurred in our infrastructure? Did anybody do any kind of release? Who has done something recently? What was the most recent change? Because this is infrastructure. If no one makes any change to infrastructure, chances are things will keep on running as it should. Except, of course, if there is a spike in your network, maybe traffic increases and it loads up the CPU, But it could be a case where somebody did a release, changed the schema of the application or the database, or anything can happen. So there are so many angles you can look at things, but you want to carefully, first of all, understand the infrastructure. You can imagine understanding an infrastructure like this, that there are proxies, there are things like that. You can immediately tell, the areas you want to start looking at things. Because if there's a problem here and users are complaining here, problem can come from anywhere. It could be a target group that has unhealthy instances. It could be a situation where our auto-scaling group is for some reason not scaling and there is zero number of instances there. It could be that, Nginx is just not working as it should. It could be this load balancer. It could be the application itself. There's so many places that things could go wrong.
All right, thank you.
Cool. So let's check again whether this has loaded. Okay, so now everything has worked fine because we have the launch template and things are fine basically. So let's go into the instances. Actually, we wanted to create the load balancer, right? Okay, so let's do that. Let's have a look at our notes. So ensure that the Nginx target group is healthy. Check the security of the instance and ensure your allows quality. Just in case it's not healthy, create root 33 and point to DNS. Okay, so we have to do some root 33 configuration as well. Let's have a look at the target groups. So this is the target group for Nginx health checks. Actually, details. Okay, healthy. So yeah, it is healthy now, which is good. Okay. All right. The next thing is we want to make sure that rather than point to this, where is it? Rather than point to this, this load balancer, we want to point to something like tooling app dot, some domain. So what I will do is I'll go to another AWS account that I have a domain name registered. So let me bring that up. So I'm using a different browser for this. So this is not a Chrome browser. This is a Brave browser. All right. So if I go to, and by the way, this is a completely different AWS account, okay? So it's not the same AWS account we had previously. So in this account, I have a domain name registered. So let's say registered domains. The domain is called DevOps Masterclass.link. So for those who are interested to buy domain, this cost me $5. So if you want to register a domain in AWS, you can just type in link. .link. It usually costs $5. Okay. All right. So I have this registered, and once you register a domain like this, AWS will create a hosted zone by default. So this is the hosted zone for this domain. So if I go into this hosted zone, this is where you can start creating DNS records. So the record we want to create here is the CNAME, and CNAME is just like you're giving an alias to something. Now there is another type of record which is AWS specific called alias. So I won't go into that today. We'll go into that, especially when you get to project 25, when we start doing some search manager and stuff like that in AWS Kubernetes. But just bear in mind, two major DNS records that you mostly work with will be the A record, which points to an IP address, a CNAME, which points to another DNS record. In this case, this load balancer address, because if we go into this console, let's go into these load balancers. And as you can see, this load balancer, it's the DNS name. See that? DNS name. So it's actually a DNS name. It's like an address. It's Amazon AWS.com address domain that points to an A record. So that means this load balancer points to some IP address. Remember, this load balancer is a managed service by AWS. So it's possible that AWS is using several servers running. It could be Nginx, we don't know. It could be Apache, it could be anything. It could be their own custom solution that does load balancing. So it's pointing to an A record of those servers doing the load balancing. So this is actually a DNS record on its own. So if we want to point a DNS record to another DNS record, we use a CNAME for that. So that's what we're going to be creating. If we were to point it to an IP address, like the IP address of a server, we'll use an A record. So what we're going to do is we're going to create a record. We can call it whatever we want. So we'll just say tooling.app, then leave the rest, .devopsmasterlink.com. So the record type we want to create is the CNAME. And then the address is this DNS address that we have here. Okay. This is the alias I was talking about. If we enable this, it's a different configuration entirely, but we'll talk about that much later. So I'm going to create this record right now. And now we can go to tooling.app.devopsmasterlink like this. And that should load up. Actually, before I do that, there is a DNS checker tool. So if you go to dnschecker.org, you can put that address here, which is tooling.app.devopsmasterlink, and then specify the type of record and search. So as long as you have all these plus, this check, green check, it shows that it's nicely resolving to some DNS record. So if we now go to our browser and pull that tooling app DevOps master link, it should load the Nginx page. So everything is good. We're hitting the Nginx. What we now want to do is make sure that Nginx is able to forward the request to the tooling app. Okay. And if we had a second app, maybe WordPress.app, then Nginx should receive it, send it over to the internal load balancer, and that should send it to the relevant application. So let's create the internal load balancer. But before we do that, let's create a security group for the internal load balancer. And what's the security that this needs? So this needs to receive traffic only from the Nginx, nothing else. So it should receive HTTPS traffic from Nginx, and then it should be able to forward it on. So let's go to security group.
So Gary.
Yes?
Can I ask a question, please?
Sure.
What's the difference between ACLs and the security group? That is a network control access list.
So the main difference between those is the network ACLs work on the subnet level. So any firewall rule you set there will affect all the servers in that subnet. Okay? But if you create security groups, it would only affect the resource that you are attaching that security group to. So if you open up port 80, for example, on the network ACL, which is on the subnet level, then port 80 will be allowed to enter the subnet. But within the subnet, you can then limit the resources that is able to receive traffic on port 80. But if you block port 80 from the subnet level, it won't go through at all. Okay, and it won't even, even if you open security group to port 80, it won't receive the traffic.
All right.
Right, so that's the major difference between the two.
All right, thank you.
Okay. So
sorry, please again. It's Megan, sorry. So is it good practice to actually enable both? Have your security group and your ACL as well?
I mean, most of these things come from business requirement. Some teams are more secure concerned than the others. And this is where business requirements / solutions architecture and network design and things like that come in. So if you're part of the design, you are going to be working based on the requirements that the business has on the level of security required. Some security concerns are driven by compliance. Okay, so it's not about whether it's a best practice or not a best practice. It's more of what do you want. AWS has made this available so that you can key into whatever works for you. So this is not a matter of best practice, right? So if you lock all your security on the network level, and then your applications are not able to accept traffic, then it doesn't satisfy the requirement because you do need that traffic to come through. So that's the way, I think about it.
Okay, thank you. Thanks.
And again, talking about best practices, best practice to one organization is definitely not best practice to another organization, right? So there are general best practices, yes, but even some best practices may actually not be a best practice to some organizations just because they have their unique requirements. Okay.
Thank you, I get it, thanks.
So we're trying to create a security group for the internal load balancer, right? So the name is MCC internal ALB from Nginx. Okay, so that we know what we're talking about. So this is internal ALB access from Nginx. something like that. At least it's descriptive enough. And then the VPC for this one is MCC, we know that. And then the rule is we want Nginx, so let's search for Nginx. So we do have security group created for Nginx already. And we want to ensure that HTTP and HTTPS are able to accept requests only from Nginx. Okay. And then that satisfies our requirement here. Okay. Now we are about to create. Yes.
I think you selected the security group for Nginx, allowing traffic from Bastion and external.
Oh, did I? Okay, let me check. Okay, so first of all, Nginx, remember Nginx does allow traffic from Bastion on SSH, okay? So maybe that was what you saw. So let's type Nginx here. Yes. So this is the only security group we have for Nginx, I believe. Okay, this is the new one we just.
You have two, one for Nginx and one for.
No. So for Nginx, now we have two because I just created this one, the internal one. This is the only one that we had existing before, right? And this one, it says MCC HTTPS SSH from ALB to Nginx. So it's both SSH, okay, and yes, for Bastion and ALB. Maybe the way I wrote it is just not nice enough, but anyway, I think it's the one that we need because we, according to our diagram, we need Bastion to connect to Nginx. We also need HTTPS to reach the Nginx. Okay.
It's okay. It's okay.
All right. So let's create our load balancer. So we're also creating a class, an application load balancer here, and then we'll say MCC internal ALB, and this one is going to be internal, and then the VPC is going to be MCC spread across the two subnets availability zones. But this has to be not the data, but it has to be, we can put it in the proxy subnet, yeah. So it's considered proxy, so we can put it in the proxy subnet, okay? And then the security group will remove the default one, and then the internal one we created, internal ALB, that's the security group we want for it. And then the listener, where do we want this to forward traffic to? So whenever it receives traffic, we want it to forward to, you know, all the applications. So WordPress, tooling, and whatever else application we're configuring in our infrastructure. So basically, where is it? Okay. So we need to create a target group first for tooling. Okay, that's one of the applications that we're going to be configuring. So instances, and then let's call it MCC tooling app. Okay, MCC VPC, leave all of that, give it a name. MCC tooling app target group. Select, okay, target group, next. So we don't have the instances yet because we haven't created any auto-scaling before. So we're just creating the target group. So we'll leave that. So we now have a target group for tooling app, yeah? So we'll go back here, we'll refresh and select the tooling app. So when it receives traffic on this, that's the default action. But once we've created these, we can do more configuration because we're not going to be relying on the default action. We actually want it to have specific actions. So this default action will only happen if no rule is considered. Okay, so let's leave this here for now. And then we can leave all the other options as default and create the load balancer. So let's view the load balancer. And then we have this here. Now, what you have to bear in mind, if we go into listener section, this is our default action. Ideally, what we want to do is we probably just want to have maybe another application running that will always return, oh, you have reached a default application or some different application, because we don't want a system where every time you go to this load balancer, that's the first thing that happens. Ideally, what we want to do is we want to create specific listeners for each of the applications. Okay, so what we can do is let's actually use the same listener. So we don't have to create a new listener. Let's use the same one because we're listening on port 80. But what we can do is we can edit the rules. So if you click on edit rules here, what we want to do is this is our default action. We can now create more actions. So with this plus button, you can now insert a rule and then start putting condition. So what we want to listen for is the host header. Okay, the host header is basically the part that's, let me bring up that page again. So we are now using, where is it? Tooling. Actually, let me close this now and use that Brave browser because that's the one we have. Where is it? Okay, yeah. Okay, so this is the address. So tooling.app.devops link, yeah? So that's the host that we're looking for. So remove the HTTP and remove this one. So anytime this address is being received as the host, the action we want is to forward it to the target group tooling app. So that's how this load balancer is going to be able to route the traffic. The moment this Nginx sends it a request and the host has the header configuration to say, this is the host that I'm trying to reach, then it knows that it is this target group that it needs to send it to. Okay, so that's the rule we need to create there. And then you can save. Okay, and then we can, I think that's done. Is there any other saving? Go back. Okay, so view rules. Just to confirm all our rules are there. Okay, so we have the rules there. Okay. So that works fine. What we now need to do.
Your two rules are pointing to the same target.
Yes. So basically, we have one which is the actual one what we want, which is this one, so that whenever it goes to tooling.app.devops masterclass.link, it goes to the tooling app. Now, this is the default one that if we reach this load balancer and it doesn't match any of these conditions, this is the default that it goes to. So this default, we could have a different target group and call it default target group. In fact, that's what we should have done rather than pointing.
Okay, I understand now.
Yes, so it's just a default so that just in case, we can have a lot of rules, but out of all the rules that we have, if none of them matches, it just goes to this default one. Do you understand? Okay. Yes, that's what that is doing there. Okay, so we have that. So the next thing we now need to do is to now go into Nginx and configure Nginx to specifically forward the request. Because what we just have is we just have Nginx installed. It doesn't have any specific configuration. So what we can then do is go into our Nginx server. So let's get the IP address. Where is so this is our running Nginx. Okay, we can get this. And now we can do SSH EC2 user at the IP address. Okay, so we've logged on the systemctl status Nginx. So sure enough, our launch template has done what we wanted to do. And now we can go into etc Nginx. Okay, so in the etc Nginx, we know that our configuration file is this nginx.conf. So without any fancy configuration of site enabled or site disabled or whatnot, we can just edit this main configuration file. Some of you're familiar with Nano, so it doesn't matter whether you're using Nano or VI, it doesn't matter. Okay, whatever you're comfortable with is what you should stick to. All right, so let's go to our load balancer. And then this is our internal load balancer. So let's get the DNS name. So this is the snippet that we need. So I've already put the snippet here. So the server block that listens on 80, and then anytime it receives this host, so this host is going to be tooling.app, DevOps master link, yeah? Then forward it to this internal load balancer. So that's the previous address I had. So this is the new address I've just copied. But this is one of the most important Nginx configuration, proxy sec header, host to this host variable. Without this setting, it will not forward this host. And if it doesn't forward this host, this load balancer will not receive that host header information. So that's why this proxy set header host is very, very important in this configuration. So that's one of the most important configuration here. So if you scroll down to the HTTP block, so this is our HTTP block here, okay? And inside this HTTP block, we now have server settings. So this is one server setting right here. So we can either just delete this, update it, or we can just put it here for now. So what we can do is I'm just going to, oops. I'm just putting tab, okay? All right, so let's just leave that as it is. And then what I will do is I'll just comment this section. So I just put a comment here to basically disable this section. Okay, so let's save this and let's test this. So we can test it with sudo nginx-t, and it has failed. I think it's all those commenting that I've just done. Let's open it back. So before you restart your Nginx, you want to do this kind of testing first of all. It's probably, okay, so we have this location and then open bracket. Okay, I think it's, okay, there is still more. So, okay, let's try, let's see. Yeah. Okay, so now it's successful. And then what we can do is we can now do systemctl restart Nginx. So you can either do restart or reload. I didn't put a sudo. All right, so with reload, it will just read the configuration without stopping and starting the service. Okay, So our service is running fine. Now, we don't have the upstream configured yet, but we do know that it will send the traffic to this load balancer. Okay, so what's going to happen is if we bring back our Brave and refresh now we're going to get 502, because what's happening is it's now hitting Nginx, which is fine. And Nginx is now trying to forward it on to the upstream. So what we need to do now is to configure tooling, create launch template, also scaling, basically clone the tooling app. And if you don't know where the tooling app is, it's in project 15. So if you go to GitHub, tooling diary, this is the tooling app right here. So just cloning this repository, putting it in the var.ww location, and setting up an Apache web service there, it will just work out of the box. Okay, so this is where I'm going to stop today and allow you guys to finish up the rest of the configuration. Let's talk about it next week. If you're comfortable with that, if you're not comfortable with it, then what we'll do is we'll have to finish this up before we go into Terraform. But if you want us to move to Terraform straight away so we don't spend too much time, because most of the things that you need now, you understand, you know how to create the launch template, the auto scaling, everything is pretty much the same. So you can replicate all the information you have now and basically get this to work. And every time you hit this URL, it should load up the tooling app. Then if you want to provision another app, maybe a WordPress, or if you're a developer and you have some app that you've developed yourself, you want to test it, you can just spin up an auto-scaling group, put your app in it, and then route your Nginx to the internal load balancer, configure your internal load balancer to then send the traffic to your app, and just go in there, we'll just load the application, and everything will work like in a snap, very fast. Okay, so we've satisfied our high-level diagram requirements. I am happy with what we have. We're good so far. Obviously, this can be improved. We can put this into containers. We can orchestrate this. We can do so much more with this. And we'll get to see how all of that works in future sessions. So I hope this has been very informative to you guys. If we have any questions, let's start talking about it now. Okay, so let me see if there are messages. So besides asking if the lag is location-based, what's the lag? I don't understand.
Okay, that was when I think someone, Nick, asked the question from his interview.
Oh, okay.
About, I was asking that, okay, I would want to know if the lag they were experienced was location-based. Right. Because a lot of things could factor into things like that. So I think it's more of a thought process question.
Exactly.
As to having a specific response to that particular time.
Exactly. So it depends. I don't know if they mentioned lag, if the problem was actually related to lag or things getting slow, because sometimes applications slowing down may actually be database queries slowing down, and that's a whole different conversation entirely if the problem is coming from the database. Okay, sometimes your application can log that information in the application log to say, well, queries are timing out, or access to the database is timing out, or it can't complete a transaction. Anything that is database specific will then require some other advanced level of understanding about databases to troubleshoot that. But at least you can get, first of all, from the logs that, the problem is relating to the database, and it could be network issues between the application and the database. It could be that databases needs to be reindexed. There are database commands that you can run to index the database, even to fix a potential blocking situation, or maybe there's a deadlock. There's so much that can happen with that. Okay, so I hope you guys are not confused. I know there's a whole lot of database commands information overload is definitely prevalent here, but that's why we have the recordings. You can watch the recording again, try to practice these things on yourself by yourself. And I'm sure now you guys appreciate the reason why we say the prerequisites to masterclass is the first 15 projects. Imagine you're starting this without the initial 15 projects, and we're talking about all of this. You just hate DevOps. You just hate the whole cloud thing altogether, because these things will just be gibberish to you. But it does take time to comprehend the concept. It takes time and practice to really soak yourself into it and know exactly how things work.
Gary.
Yes.
Yeah, I got a question. I don't know, is it because from the example you did creating the CNAME of the domain, you didn't attribute the www 3 times. You just put directly from tooling. Is that okay?
So those things sometimes depend on the browser.
Yeah.
Okay. So it just makes sense to also put it, just in case your users are using some kind of browser that are not as intelligent as you would expect it to be. So it's just like a fail-safe approach to, just in case a browser is not able to understand that, just put in the host, it also needs, it should have www by default. So what you would do in such cases, in some cases, that when you're creating your CNAME record like this, you can just create another one, like a duplicate, that will have that. So you just put at the start www. and then put the balancer address there. Make sure it's a CNAME. So that works. It's just a way to say, okay, just in case the browser doesn't work well, because some browsers have some restrictions over the others. I mean, Chrome, for example, does not like to work with applications that do not have trusted certificates. So when we start working with Kubernetes, you will see a lot of examples with things like that. And then when you go to another browser, it works just fine. So
okay. I experienced a problem in project 15 with my DNS. So sometimes you have to watch your certificates, especially on Chrome browser. If you put your www, or maybe like my own case, I had 2 domain names. One has www. And the other does not have.
Yeah.
So, but Chrome defaults everything to www. So, and when I visit my app on the browser, because my certificate only covers one subdomain, it will be showing me insecure app. So you have to be careful when you write your like on the long and short. I just used a domain name without www to avoid those Chrome issue. But it was working on Edge browser. Microsoft Edge browser, it was working fine.
Yeah. So usually a browser thing that you just sort of put some configuration in place just to satisfy some browser requirements.
Okay, thank you.
Okay, all right. So guys, if you haven't completed your Terraform courses, this week is what you want to spend time doing. As much as you can, try to finish up Terraform, okay, before we meet next weekend. Because that's what we're going to start with. Everything we've done here, we're going to see how to write the Terraform code, how to refactor Terraform code, how to do things like that. And then we can just switch over to containerization after that. Okay. All right. So thank you very much, guys. I wish you the best week ahead, and we'll get to see you again next weekend.
All right.
Yeah, thank you.
Thank you. Good night.
Thank you. Good night. Thank you.
Recording stopped.